pleasure to be present in an August gathering like this after so many months of doing webinars. It is one of the first public event where I'm actually speaking. And it's actually a pleasure that we have a fairly good turnout here. Today we would be doing a discussion primarily on IoT and intelligent lighting. Well, IoT is a term which people have been throwing around just like everything, like, Internet of Things. And then there is also intelligent lighting. Now, what I'm trying to do is I'm trying to look at how we can break down what is IoT, what is intelligent lighting, and how the convergence of two can bring about change in our lives. So let's first look at what is IoT, or Internet of Things. By definition, the Internet of Things describes physical objects or groups of such objects that are embedded with sensors, processing ability, software and other technologies, and that connect and exchange data with other devices and systems over the internet or other network devices. So what it basically means is Internet of Things basically makes things easier for us. It's as good as me giving a voice command and an action happening, or a very refined action happening over a period of time, depending on how a processor understands and collects a lot of data and interconnects between technologies. So basically, the interconnection of technologies and giving us the right kind of output is what Internet of Things is all about. And then let us look at what intelligent lighting is all about. Now, intelligent lighting, I'm just going to give a brief history of what it is. We started with possibly a switch-on, switch-off button, which would turn on and turn off a light. It was not that intelligent because we are manually doing it. The first set of kind of intelligence that came in was timer-based controls, where you would have a timer-based system which would set the lights to come on, come off. And then the next advancement, which came in around 1995 to 2000, was the occupancy sensors. And the occupancy sensors, what it did was, based on occupancy, it would switch on and switch off the lights. Then the other advancement which came was the daylight sensors, because we saw that there are ample amount of daylight available in large spaces, but the electric lights are still on during these times. And that is when daylight sensors came in. And again, daylight sensors originally were based on a threshold light cutoff. So it was like set to say for 400 or 500 lux. So when daylight comes to that, it just cuts off the light. Then came the combination, which was occupancy sensors with a daylight override, which means if there is no occupancy, the lights would switch off. And if there is ample amount of daylight, then also the light would switch off. Then came the further advancement to that, where dimming came into the picture. Then you had dimmable oculux sensors, which were a combination of either an analog sensor, which would do 0 to 10 volt based dimming, or a digital signal interface, or a DALI system. A DALI would be a digitally addressable lighting interface. So oculux sensors made a big difference in terms of how lights would dim up and dim down based on occupancy as well as daylight. And this was really a breakthrough in terms of how the further advancement in lighting management systems happened. But again, during these times, 2000, 2005, you had a lot of plug-and-play devices, which were intelligent devices. So one of the companies in UK, Danlers and Exor, I guess, came up with something called as a dual circuit sensor. So what happens is you have two outputs from an occupancy sensor. So you can dim up and dim down based on daylight and occupancy. You had a remote override with which you could then set the lux levels. And when you leave the room, it kind of switches off. But for example, if you have a cabin and you have one suspended light and a cove light, that's typically what you have. So the cove light is on one circuit and the other one is on the second circuit, and you can switch on and switch off them independently. Then came what we call as the networked sensors. This is where you had a group of sensors. So for example, if you had a large corridor or a large space like this, what was happening was one sensor was not able to cover the entire space. There was a limitation. So you had a set of sensors which were interconnected, still standalone, which would talk to each other, and if there is occupancy detected from any of the sensors, it would turn on the lights. So that was the networks sensors, which also was the beginning of a lighting management system. Then came the intelligent multi-sensors, which was a combination of occupancy, daylight, heat map, temperature, humidity, all of these together in one sensor. And one of the companies which came up with the first intelligent multi-sensor was Enlighted. Then you have, of course, the basic lighting management system, which was either DALI-based or Zigbee or KNX-based, different kinds of this thing, where you had a lighting management system where you could have a kind of server with which you could see the entire space. It is a two-way DALI communication which would tell you whether the lights are on, how many hours, what are the burning hours. In terms of the basic lighting management system, the advantage was you were able to get data in terms of, how many hours they were working, or if there is a failure, how it can be detected, and stuff like that. Then came the advanced lighting management system with soft wiring capabilities, where you had two mesh systems, so it was completely independent. So you had an electrical system which would do the basic power, and then you had a digital, either a DALI or any of a PoE kind of a system, which would kind of give a separate control. So you could switch off a light by dimming it down to 0. So that way you could control them. The advantage of this was you had something called soft wiring, where if a space was getting reorganized, what would happen is if 4 lights were connected together physically, you don't have to physically change them to change it. All you need to do is change the soft wiring in the software, and automatically another set of lights could get connected to each other. So this was the advantage of the advanced lighting management system. And this could also then feed data, because by the use of multi-sensors, they could also feed data to the BMS and then ask the BMS to further control HVAC and a lot of the other devices. Advanced LMS also helps in controlling the blinds. Automated blinds is one of the key aspects where, depending on the daylight availability and depending on the luminance of the sun's rays, the drapes could go up and go down. Then, of course, you had the power over Ethernet, because this was something which became popular a couple of years ago when they thought everything in an office is connected through an Ethernet cable. Why not have the lights also connected to it? To some extent, it worked well, but then what happened was the cabling with this was extremely cumbersome. And plus, if you had to retrofit stuff later, because they were not built-in driver, they had a separate driver which would so it was a driverless kind of system. Then you had, of course, the hybrid LMS with seamless IBMS integration. It's a combination of, let's say, PoE plus DALI, a mixture of all of that. So let's look at how, so this is kind of the basic evolution of what intelligent lighting is all about. Now, why intelligent lighting? Of course, fundamentally, why we use intelligent lighting is for energy saving. Then, of course, for flexibility in creating scenes. Well, with the recent development of circadian and tunable white lighting, of course, it's become very important, because without a control system, you cannot tune them. So circadian lighting and daylight integration, this is also one of the reasons why you would need intelligent lighting. Energy management and soft wiring, failure detection, which I already discussed in terms of the lighting management system. HVAC and blind control, which can be controlled either directly through an LMS system or through the BMS system. Effective space utilization, providing Li-Fi, light fidelity, which is the trend going to be the future. 5G plus, we'll discuss that in detail. And then, of course, location services in interior spaces, like an interior positioning system or location system. These are why we would use intelligent lighting. Now, as a lighting consultant, I wanted to actually understand why we use this, what are the basic applications in a commercial interior space, and how technology is to be used in the right way. Because what I've seen is this integration between what actually happens in a space and what is actually required from a lighting controls company is usually never merged. So I'm just looking at typical various kinds of office spaces. So if you look at an open office space, let us look at the most advanced scenario. You have something like a suspended up and down lighter. The upward component could be tunable white, which can be a circadian lighting system. So your ceiling becomes like the sky, how the color temperature changes from morning to evening. And the downward component could be dimmable 4000K, which can then vary between 3500 to 5500, depending on how the color temperature is changing upward. And then, of course, you have that large glazing up there, which requires automated blinds, because that will also control the amount of daylight coming in and maximize the daylight and the views outside. Because normally what happens is in the morning when the sun's rays are very glary, people just draw the blinds down and they never draw it up back. So throughout the day, you are never seeing what's happening outside. You're not experiencing daylight. The idea here is, in an open office space, you want the combination of the two. So both have to have an interplay. So whatever is happening outside should also be happening inside, and it should also be energy efficient. So what you could use is something like a DALI smart sensor, or any smart sensor for that matter, which basically detects occupancy and daylight availability and dims up and dims down the artificial lights. And then you could also have some luminance sensors which can be stuck onto the glazing, which basically detects the rays of the sun, and it actually brings down the blinds depending on the luminance or the glare, because if the light is glare-free, it is okay to have the blinds up. So that's where, that's the basic requirement of an open office space. And this is what I was talking about, luminance-based window control, where even if, for example, if there is another glazed building next to your building, and the sun, even though it is at 12 noon, it's right up above, it can still reflect, and you could get a reflected glare. And that is where luminance sensors really helps, and it kind of adjusts the drapes depending on the glare from the sun. If you look at now a cabin scenario. Now in a cabin scenario, what happens is you usually have one suspended up and down lighter and possibly another circular discussion table light. So all you need is a smart sensor where, so a typical scenario here is, let's say if you're doing a circadian lighting office, then you, of course, when you walk into the cabin, you want all the lights to come on, but they should also be, because these cabins usually sometimes they have, if it's a corner office, of course, you have good daylight availability, but if not, what happens is it should run on the same circadian cycle as what is the color temperature outside. So it will run on a circadian software, and then the occupancy sensor turns on the lights to that particular color temperature of what is exactly happening outside. The person should be able to, with a touch panel, control the lights up and down, depending on whether he wants to keep one on or off, or change the color temperature or dim up and dim down. And when he leaves, the lights kind of turn off. And when he comes back in, then the same scenario gets repeated. Sorry. Then coming to a meeting room scenario. In a meeting room scenario, again, most of these meeting rooms nowadays are also VC spaces. So video conferencing becomes very important. So from a lighting perspective, when you look at it, you want to have a light which does not create any kind of reflection on the screen. At the same time, it should also be able to enhance your faces very well. So you possibly use a tunable white suspended up and down lighter like this, which gives a very diffuse light and avoids all kind of shadows. And at the same time, what is one of the studies which we did showed that different skin tones get enhanced differently with different color temperature. So we have different people with different skin tones. So depending on the skin tone of the people using the meeting room, you can set the color temperature in that room to 3000 to 2700, 6500. Whatever they feel He is kind of best. So what we use in this kind of a scenario is again a smart sensor which will turn on the lights, and you have a small 4-pad or a 6-pad scene select system which can, based on whether it's a presentation mode or whether it is a video conferencing mode, depending on that you will be able to set the different scenes. Otherwise it runs on a standard circadian cycle. Video conferencing room becomes a little more complicated because you have much larger space there where the functions of a video conferencing room would be general conferencing, LED presentation, video conferencing, or a whiteboard presentation. So you need to ensure that you don't get any kind of reflections on the screen. At the same time, your faces are well illuminated without any shadows. So you usually use a dual optics like this. So if you see here, you see there is a central optics which is tunable with a diffuser, which can be turned on during a video conferencing. In fact, if you see in this picture, the central optics is not turned on. It's only the laser blades which are turned on, which is generally required for a general conferencing. And then when when a VC happens, you turn on the other ones, which can again either run on a circadian or depending on who is speaking and depending on the skin tone of that person, you can adjust the color temperature to their requirements. So typically you divide the lights into 4 different zones in a conference room. Typically that's the kind of layout you have. You have one sensor which will detect occupancy, and then you have a 4 or a 6 or an 8 keypad which would set different scenes depending on the applications. So this is one of the projects where we did a Barisol ceiling with a Barisol ceiling with tunable white, where you see how the color enhancements actually varies from different color temperatures. It's not only the enhancement of this, the skin tones also similarly gets enhanced. Typical circulation spaces where with a tunable system you could have different color temperatures depending on the type of the day, and you would have connected dimmable sensors, because once they're tunable they're automatically dimmable. So you use a combination of dimmable sensors which will then control the lights dim up and dim down based on occupancy in the passages. So that's what intelligent lighting and the application is in a commercial office space. So let us look at how the integration between an IoT and a lighting management system along the BMS happens. So typically you have multiple sensors which will collect data. Through a gateway, it then transmits all of this into, or through an LMS system, into a BMS system or to a cloud where all of the data gets processed and crunched. And then what IoT actually does is refine this data and give feedback to actually make life easier for us. That's where it comes from. So this is typically how you would have sensors all over the space which would collect data in terms of heat map, in terms of all of it, the multi-sensors. They transmit data through the gateway to the server, and then it is fed back to control the HVAC systems or all of the other systems. So what are the advantages of LMS with IBMS and IoT? So one of the key aspects is real-time location services. So you're able to locate people and things inside a large commercial space. Interior wayfinding. So like I said, geolocation or navigation within a large mall or spaces like that. Safety and security, where you can do smart surveillance. You can have emergency response. Space utilization, where you could look at space usage, mapping, meeting room allocation. So, these sensors give data back to the system in terms of whether the meeting room is empty and somebody else can book the space. Workflow optimization happens because of this. And then, of course, energy management, which was the conventional lighting management system part where we do optimization of the lighting, HVAC optimization, and automated blade control. So that's what is the gist of all of it. And of course, light fidelity. So what light fidelity is, it's a mobile wireless technology that uses the visible spectrum of light rather than radio frequencies to transmit data. The technology is supported by a global ecosystem of companies driving the adoption of Li-Fi, the next generation of wireless, that is ready for seamless integration into 5G core. So I would end my keynote with a small video on light fidelity.
Could connect you to the internet. Lights in our homes, offices, cars, and even street lights, connecting us to high-speed wireless internet. Li-Fi is high-speed, bidirectional, fully networked wireless communication, allowing us to give the light we use to illuminate our spaces another purpose: connectivity. Li-Fi enabled LED lights modulate illumination levels to send data like Morse code. This modulation happens so fast the eye can't perceive it. Li-Fi is where light becomes data. Every year, the world consumes 60% more wireless data. Almost all of this is consumed indoors using wireless internet connections that utilize radio frequencies. The space for radio frequencies is becoming oversaturated, resulting in what is known as the spectrum crunch. Eventually, radio frequency technology like Wi-Fi will no longer keep up with demand. However, Li-Fi does not use radio frequencies. It uses the light spectrum, which can open up 1,000 times more spectrum than radio. Li-Fi will be an integral part of the future of wireless networks, such as 5G. Li-Fi, a world with unprecedented data and bandwidth. Be part of the light revolution.
Well, so I guess I end my keynote with this. This is the enormous possibilities of how lighting management systems and IoT integrated together can be the future and how things can make better for all of us. We have a lot of other speakers who are talking on similar subjects. So I think most of these aspects which I touched upon will be touched upon in detail with all of these speakers. Thank you very much.